This is Note-Taking Guide 3.1 for Math 1. Today we're going to talk about functions and how we can determine whether or not something is a function. So the definition of a function is up there at the top of your note-taking guide. It says a function is a set of ordered pairs in which each element from the domain or the set of all x coordinates is paired with one and only one element from the range or the set of y coordinates. So that's kind of hard to understand. So what does that actually mean? That means that each x value can go to only one y value. So what we're going to do is we're going to look at some examples here of some relations and determine whether or not they're functions. So let's just start by looking at this set of ordered pairs right here. This is in a table of values here. So let's just kind of look at an ordered pair at a time. This ordered pair is -2, -4, if we were going to be writing that down as an ordered pair. We have an ordered pair -1, -3, 0, -2, 1, -1, 2, 0, and 3, 1. So what we want to decide here is we want to decide if every x value goes to exactly one y value. So what I'm going to do is I'm going to just go through my x values and I'm going to see if any of them repeat. Because if my x values repeat, then that means that it's going to more than one y value. So -2 is my first x value. Does -2 go to, is there any other -2s along here? There's not, which means that -2 only goes to one y value. So -1 only appears once, 0 only appears once, 1 only appears once, 2 and 3 only appear one time each, which means they're only mapped to one value. So to answer the question, is this a function? The answer would be yes, because each x value goes to only one y value. Okay, so let's continue looking at these now in different, and use some different strategies or different ways to look at them to determine whether or not the relations are functions. So this second one is called a mapping. It's where we have numbers mapped from one set of values mapped to a second set of values. So when we're looking at B over here, we can see, again, we're going to check to see if our x's are mapped to only one y. So 3 goes to exactly one number. 1 goes to exactly one number. I'm sorry, that's 0. 0 goes to exactly one number. -3 goes to exactly one number. Even though it goes to the same y value, it's okay because it was a different x value. And then -6 goes to exactly one y value. So this, again, is a function because every x value goes to only one y value. Now, how would we have known that this was not a function? Well, in this case, maybe 0 would have gone not only to 0, but maybe 0 would have also been mapped to 2. If that would have happened, then we know that that would have been not a function. But because that's not what happened, because every x value went to exactly one y value, the answer again is yes on that. All right, let's look at example 3. So again, we're looking at x values and deciding whether or not they're mapped to exactly one y value. So we have an ordered pair 0, 3 here. I want to look and see if that 0 is repeated anywhere else in my x values, and it's not. So that first ordered pair is good. I'm going to check my next ordered pair. I'm going to look at the x value. It's 1. I want to see if that x value is repeated again in any of the other ordered pairs, and it is right there. Because that x value is repeated, that means the x value gets mapped to two different places. That 1 is going to 4, and that 1 is also going to -1. Because it gets mapped to two different places, this is not a function. Now the last one is looking at a graph and deciding whether or not it is a function. So how are we going to tell? Again, we're going to check our x values. This is our x-axis. This is our y-axis. So the x value here is -4. The x value here is -2. The x value here is 4. The x value here is 1. This has an x value of 1, and this has an x value of 1. So this is not a function because the x value is mapped to two different points. Again, that we would have that ordered pair 1, 1 for the first one and 1, 3 for the second one right here. And because that 1 gets mapped to two different spots, this is not a function. So someone came up with a rule for that to try and make it easier to understand. That rule is called the vertical line test. So if we're looking at a graph of a function, we can decide whether or not it's a function by simply drawing vertical lines through the relation and see if it crosses more than one time our graph. So if I draw a line here, it only touches my graph once. If I draw a vertical line here, it only touches my graph once. If I draw a vertical line here, it only touches my graph once. Actually, every time I draw a vertical line through my function, it's only going to touch once. When that happens, it is a function. But on the other hand, when you draw a vertical line through and it touches your graph more than one time, like in this case 3 times right there it touches your graph, that will determine that it is not a function. So let's go back and look at this example E that's on the same page. If I draw a vertical line through this, it touches my circle here and it touches my circle here. So this is not a function because it touched my graph more than one time. All right, we have 4 more examples here to look at. We're going to just quickly do the vertical line test through it. Again, and you got to kind of sometimes draw more than one vertical line to make sure that your graph isn't going to touch that vertical line more than one time. But no matter where I drew my vertical lines, I only went through the graph one time. So this is, yes, it is a function. Now this is an interesting one because look, if I draw my vertical line through this graph, it touches every single point all the way through, so like a million times, like actually infinitely many times. So because it touches the graph constantly, this is not a function. All right, let's look at this mapping right here. Again, let's decide whether or not this is going to be a function. So we're going to look and see if every x value goes to exactly one y value. So the negative 9 is okay. The 5 is okay. The 1 is okay, but look what happens with the 7. The 7 goes to 2 different numbers. So because that 7 goes to 2 different numbers, this is not a function. All right, one last example here. This is a line. So y equals 2x plus 1. How are we going to tell whether or not that line is a function? Well, you guys, let's talk about it for just a minute. So let's graph it and see. If we go really fast on a graph, my y-intercept is 1, so I'm going to be right here. My slope is 2, so I go up 2 and over 1, and my line goes through that set of ordered pairs. Now visualize drawing a vertical line through that anywhere along the way. Will it touch the graph more than one time? The answer is no, it will not. So this is a function. Yes, this is a function. So did I know that before I got started? I did. I actually know that lines, really any kind of line, is a function. The only kind of line that is not a function is that vertical line. Vertical line, so one that goes this way would be a function, yes. One that goes this way would be a function, yes. One that goes this way is not a function though, because of the way that a vertical line works. All right, you guys, thanks for watching. Good luck with your homework.